Okay folks, this week we're going to carry on with trig. We're going to look at something called the sine rule. We're going to look at a different way of finding triangle area. It is all popping off. Let's go. So we've already talked about labeling triangles. We've drawn right-angled fellows and we've said that this is the hypotenuse, and we've talked about like opposites and adjacents. And there's a sort of a different system in play for when triangles are not right-angled, because there's no right angle to sort of base everything off of. If we just have a generic triangle of sorts, then we just label the sides whatever we want, but we label the sides with a lowercase letter. So I call this A and B and C. And then you can label angles whatever you like, but they're uppercase. But sides are opposite angles. So if this is side A, then opposite it is angle A. So we've got angle A down here. If this is side B, then angle B is opposite it. If this is side C, etc. Okay, so there's nothing more complicated to it than that. You can label them any which way you like, but sides must be opposite angles. So with that golden rule in mind, you can introduce something called the sine rule, which here is the bit that you absolutely need to make sure you know. This is A over sine A, and remember we've got lowercase sides and uppercase angles. So let's see how we'd actually apply this. As far as we've got a little 1, 2, 3 method, we want to label our sides, stick them in the formula, and then sort of multiply across. So let's do that with this first example. First thing we need to do is label our sides. Now, you've got loads of sides to this triangle, so how do you decide what you like? Well, I would call the sides that are in the question A and B. I think that's always useful. So 9 is in the question, I'll call it A. X is in the question, I'll call it B. This side over here is C, but it doesn't have anything written on it, so I'm just going to ignore that for now. And then angle A is opposite side A, so that's the 85, and angle B is opposite X. So that's what we got there. So we've labelled our sides. Done step 1. Put into the formula. So the formula says A over sine A. Let's actually write this out first before we do anything. Is equal to B over sine B. It's in theory equal to C over sine C, but there's no C in the question. We only need these bits. Okay, done that. And then multiply across. Oh yeah, we actually need to put them into the formula. So instead of A, we're obviously going to write 9. Instead of sine A, we're going to write sine 85, because that's what we labelled as side A and angle A. For B, we're going to write X. For sine B, we're going to write sine 45. And then finally, step 3, multiply across. So we're actually going to take this sine 45, which is underneath the X, and we're going to multiply the other side by it. So we end up with something that looks like this. Sine 45 times 9 over sine 85 equals X. Now, you then need to stick that in your calculator, and we should get out of that X is roughly equal to 6.39 centimeters, because we've got centimeters on the question. Make sure that you actually do get that. Stop the video at this point. Make sure you get the same answer here, because if you're subbing that in wrong and you're getting like 12, you've got to make sure you fix that first. Okay, there are 2 more examples here. I think it's probably worth you guys having a go. So pause the video, have a go, and I'll be right back with you in 3, 2, 1. Okay, hopefully you have had a go. I'm going to run through these though. So again, label our sides. So we've got A and B. Label our angles, A and B. Fill them into the formula. So 3.4 over sine 30 is equal to X over sine 78. Multiply across by the sine 78. We'll get sine 78 times 3.4 over sine 30 is equal to X. And you get a final answer there of 6.65 centimeters. Okay, let's have a look at the second one. Label the sides. We'll call this one A and this one B. Label the angles, A and B. Fill them into the formula. X over sine 115 is equal to 25 over sine 22. Multiply across. X equals sine 115 times 25 over sine 22. Stick it in your calculator. And we'll get out of that 60.48 millimeters. Okay, hopefully that makes sense now. The first exercise on Heggerty is basically that. Now I think it was worth having a look at some slightly more difficult versions of the sine rule, where you're still using the same thing, but there's like bits labelled on the diagram that you might not want. So in our first question here, we've got all three angles labelled up, and we need to just pick two of them. So how do we do that? Well, we label the sides that we're interested in. That's 5.7 and x. We label the angles that are opposite those sides. So that's our A and that's our B. And then we just ignore the other one. Just like put it out your mind, forget about it. Sub stuff into the formula. 5.7 over sine 40 is equal to x over sine 71. Multiply across. And sub it in your calculator. To give us 8.38 centimeters. Okay, what about this one here? Now, what's difficult about this? Because we've got our two sides, so we'll just label this up as A and B, and then we'll label this as angle A because it's opposite the A, and then here's angle. Oh, we don't know that. So, the problem with this one is the wrong angles are labeled, and you've got to make sure that the angles you pick are opposite the angles, or opposite the sides that you have. How could we work this angle out? Well, it's a triangle, and triangles have their angles add up to 180 degrees. So all we need to do is take away the two angles that we know. So that's what 118 take away at 62. And there we go, we've got angle B. Now we want angle A, we want that 54, we want angle B, we want that 62. Ignore that 64. You only need two of each. Fill in your diagram, so A over sine A is B over sine B. Multiply across. And stick it in the calculator. And we should get there 3.39 meters. So yeah, that's how they can try and trick you. Thought it'd be useful to finish off with a slightly more complicated question, which brings in some of the trigonometry we'd looked at last time round. In this question, we have to find this missing side H, and we've kind of got two triangles involved. Now, one of them is a nice right-angled triangle, that's great, and one of them is not. So how are we going to do this? What would your approach be? So what we can do is we can try and fill in some angles first, because angle rules in triangles are a little bit easier. This angle here, for instance, that's just 148 because it's on a straight line with the 32. And if we know that angle, we also know this angle because we've got a whole triangle there with a 148 and a 26. So if we take them away from 180, we'll get that there's not a lot left there. There is just 6 degrees left over. So that there is 6 degrees. Okay, great. Now what? Well, what would be useful? What could we actually figure out here? Well, we could use this triangle here, which has got its 6 degrees and it's 148 and it's 26, and it's also got this length here as being 40, and we can try and find another length. So let's say that we want to find this length, maybe. Yeah, that makes sense to me. So what do we want? Well, it's this sine rule, definitely, because this is not a right-angled triangle. We would like the angles that are opposite the 40, so that's 6, and we want the angle that's opposite x, so that's 26. Okay, great. So we could maybe label up our sides here. We've got angle A, side A, angle B, side B. And then we could stick this into the formula. So we've got 40 over sine 6 is, not 66, is equal to x over sine 26. We could multiply across by the sine 26. And we could say that's equal to x there. And we could get there that x is equal to 167.8. Okay, great. That's still not what h is, but maybe it makes our life a little bit easier. So let's change that on the diagram. We've got that this is 167.8. Okay, now what? Well, maybe we could consider the right angle triangle now. Maybe we've got enough information on that. So our right angle triangle, this is the old BCD. We want to find h. We know that this is 167.8. We know that this is 32 degrees. And, well, we could use the sine rule here, actually. So let's use the sine rule. You could also use SOHCAHTOA though. But that's a 90-degree angle. And that's opposite our 167.8. So let's call that angle A inside A. Let's call this angle B inside B. And yeah, we can just stick them in the formula, can't we? We can say this is 167.8 over sine 90 is equal to h, whatever it is, over sine 32. So multiply across, same as normal. And we'll get a value for h, which is going to be 88.9. Now there are actually quite a lot of different ways of doing that question, so you might want to have a go at it with your own favoured system. You should end up with something in the same region though. Okay, so throughout that process I was noting down that we were finding side lengths, and there is kind of like two versions of the sine rule. There's one where we've got the sides on the top, and there's one like this where we've got angles on the top. And the thing on top is generally what we're trying to find. So this is an angle version. It's exactly the same formula rearranged, but it's a much more useful one when you're trying to find angles. Again, written down a little 4-step process here. We want to label the sides, put them into the formulas, multiply across, and we've got an extra step now. We're going to use sine -1 to try and find the angles, just like we did with SOHCAHTOA. So let's label up our triangle. Let's call this A and A. Let's call this B and B. And let's use this other version now. So we've got sine A over A. So we're going to say sine 75 over 8 is equal to sine theta over 5. Okay. Step 1 been done. Step 2's been done. 3, multiply across. So we're going to multiply across this time by a side length, by the 5. So it's by whatever's on the bottom of the fraction. So we've got 5 this time. Lots of sine 75 over 8 is equal to sine theta. And if we type that in, we'll get a lovely decimal 0.604 or thereabouts. And then to find our angle, we want to use sine -1. So we're going to use sine -1 on our 0.604, and we'll get 37.1 degrees. Okay, same as before. Try and type that stuff in. Make sure you're getting the same answer I am. If you're not, you need to let me know. But let's try and apply that on 2 more. Now again, I'd like you to have a go first, so I'm going to assuming that you're doing that now and you're unpausing the video in 3, 2, 1, let's go. So label our sides, label our angles, put them into the formula, multiply across by the 16 rather. So we'll end up with sine theta is 16, lots of sine 80 over 35. Type that in and you'll get that sine theta is equal to 0.450, and then use the sine -1 button to find the actual angle, which is 26.8 degrees. Hope you got that right. Let's do the second one. Label the sides, label the angles that are opposite them, put this into the formula, so we'll have sine 120 over 40 is equal to sine theta over 30, multiply across, so we'll multiply across by the 30 this time. Remember, we're trying to get that sine theta on its own. Type it in, and we'll get ourselves 0.3 6495 or something. Use sine to the -1, so this is step 4 now. And we'll get that our angle that we want is 40.5 degrees. So yeah, it's one more step than the previous one we're looking at, but it's a way to find angles as well as finding sides. So again, here are two slightly more awkward ones. They've got pretty much the same tricks that we had last time round, to be fair, but let's have a quick look. So our first one is dastardly because it gives us 3 sides, and we don't want 3 sides, we want 2 sides. So again, label the angles that you're interested in, label the sides that are opposite them, and then you don't need to worry about that. It's really important that you narrow down your focus to 2 sides and 2 angles that are opposite each other. Everything else makes sense. So then we can stick it in the formula. We've labeled our sides. So sine theta over 7 is sine 78 over 10.652. Multiply across, sine theta equals 7 lots of sine 78 over 10.652. And we should get that that is equal to 0.643. Use the sign -1, or the inverse sign, to our 0.643, and we'll get that the angle is 40 degrees. What about our second one? What's awkward about this? Well, again, we need sides to be opposite angles. So we've definitely got, and I'm going to actually scribble these out as well. I always find them annoying. I want to label them my own way. So we'll call this angle A and side A. We'll call this side B. And then we've got an angle over here as well, which is not opposite it. So is that angle C? I guess we're going to call this one B for now. Yeah, so the way we're going to do this is we're actually going to find this angle at the top. And then we're going to just use the fact that angles in a triangle add up to 180 to work out what theta is. There's not really any other way of approaching it. Okay, we've labeled our sides. We'll do our formula. So sine A over A is equal to sine, what should we call this angle? Let's call it X. Sine X over 8. Multiply across, so 8 lots of sine 120 over 20 is equal to sine X. That's equal to 0.346. Then we'll go shift sign with that and get that the angle that we wanted is 20.3 degrees, but we're not quite done because the actual theta that we're after, that's going to be equal to 180, take away 120, take away 20.3. Should end up with 39.7 degrees or something like that. So yeah, even if they are pointing at, I guess, a different angle than the one you want, you can always just use triangles adding up to 180. Okay, here's about as fiddly a triangle question as I can put together. Again, well worth a pause at this point, but I will assume you've done that and come back in 3, 2, 1. So we're trying to find this angle up here, and we know we're going to have to use sine rule to do it because this is not a right angled triangle. We've kind of got a side opposite an angle here, so that's good. So what we want is the side opposite this angle. We want to try and find this length. Okay, how can we do that? Well, we could consider this right angled triangle on the right hand side. So let's do that. Let's draw out what we know. We've got a right angled triangle, length of 16, an angle of 49, and a side here that we're trying to find. I'll actually call that Y so it doesn't get mixed up with the hypotenuse. And this is a point where we do go back to SOHCAHTOA again. Label up your sides. So we've got opposite and adjacent, which means that we're going to use TOA. We are trying to find the opposite angle. So we know that opposite is equal to tan theta times the adjacent. So it's equal to tan 49 times 16. So it's equal to 18.4 or thereabouts. Okay, great. So now we can rule out the fact we've got y, that's what we found, and we can write it on the diagram, 18.4. Okay, so we can now consider the other triangle, which has got a length of 20, a length of 18.4, an angle of 35, and an angle of x that we're trying to find. And now we can use the sine rule. So label them up. We'll call this side A an angle A, side B an angle B. Let's maybe draw a little dividing line in. Put them into the formula. So we're going to say sine 35 over 20 is equal to sine x over 18.4. Multiply across. Type it in, so we're going to get that sine x is equal to 0.528. And then we want to use, again, shift sign here to work out what x is, which is going to give us 31.8 degrees. So yeah, a SOHCAHTOA, then a sine rule. That's really getting towards that sort of grade 7 or 8, whether you want to do multiple ones of these together. Now there's a couple of other bits and pieces of trigonometry on the course, and I thought this was a good time to bring in the area of a triangle formula. I know you already know one of them in terms of a half times base times height, but there can be situations where we don't know the base or we don't know the height, and we do know the angles, and there's another formula that will work here, which is that the area of a triangle is a half AB sine C. Now what do we mean by AB sine C? Well, we kind of talked about that. Angles are obviously opposite sides, so if we had A and B, those would be our angles A and B. So this must be side C, so this must be angle C. So if you strip it down to what it's basically about, it's about any two sides and an angle between them. The A is one side, the B is one side, and the C is the angle in between those two. I always think that's an easier way to do these questions than having to label them up. So we've got here 14, an 8, and a 70 in between them. So this is going to be our A, this is going to be our B, and this is going to be our C. So let's find our area. We just need to do a half times 14 times 8 times sine 70. That's going to give us an overall area there of 52.6 centimeters squared. Yeah, simple as that. Stick them in the formula and we're done. What about this one here? Well, we want two sides and we want an angle in between them. So the side we're not interested in is this 6.6. We want the side 9, 9.5, and the angle in between them. So our area is going to be a half times A times B times sine C. And that will give you 28.6 centimeters squared. So if you remember that whole angle in between two sides, you're good. Let's see if we can increase the difficulty a little bit. So all you can really do, apart from obviously applying maybe sine rule to it, is you could require you to rearrange the formula. So these are some examples where you have to do that. We're given the area and we're told to work out the side length. So how would you do that? Well, we know that area is equal to a half AB sine C. It's always worth writing down your things before you start. We know that area is 24 in this question. We know that A is, I guess, 6. We know B is maybe Y. And we know sine C is sine 110. So what do we do with that? Well, if we wanted to get the Y on its own, given it's being multiplied by all of these things, we should divide by them. So we should just do 24 divided by a half times 6 times sine 110. And that will just give us Y, which you should get to be about 8.5 centimeters. Okay, let's try and do the same thing. Area is a half AB sine C. This is our A, this is our B, this is our C. So 9.22 is a half times 5 times Y times sine 32. So again, we've got Y being multiplied by all of these things. So the simple approach is just to divide by all of these things. So we'll divide by a half times 5 times sine 32, and we'll get ourselves to Y being 6.96 centimeters. So yeah, not too bad if it's a side you're after. And then if we're approaching something like a grade 8 question, it could be something like this, where we have to find the actual angle. So again, let's write down our formula, half AB sine C. Our two sides are 16 and 10, so we've got, and our area is 78.5. So a half times 16 times 10 times sine c. And then we'll do the same thing. We'll divide across by what we found, by that half times 16 times 10. And we'll get the 0.98125. Now, if you know sine c, how do you find the angle? Yeah, it's that thing again. It's that shift sign. So we're going to do sine minus 1 onto that 0.98125, and we'll find that the angle that we're after is 78.9 degrees. What about if we apply the same thing over here? What's different here? Well, this is an isosceles triangle. You can tell because of the matching sides. So if this is 8, then this is going to be 8 as well. So the first thing we do is have to recognize that. We're after an angle, we've got an area. So again, let's set up the formula. Half AB sine C. Fill in what we know. Area is 16. Two sides are both 8. And the angle in between them we don't know. So we should divide. We should do 16 divided by a half times 8 is equal to sine C. Stick that in and you should get that it's equal to 0.5. And then how do we get rid of the factors of sine there? We use sine minus 1 on that 0.5. And that should give us that the angle we're after is 30 degrees. So yeah, area of a triangle and 3 ways you can rearrange it.